Hello YouTube and welcome to yet another full stack app tutorial, and in this episode we will continue on from where we left off previously, which was creating some middlewares and doing a ping router. Now we're going to create our user router, so that will enable our users to log in, register themselves, refresh their bearer tokens when they expire over a period of time, and also some aspects like updating password. So to start off, we are going to create actually a couple more middlewares that we didn't need for the ping one, and that is to validate incoming requests and also to authorize some of the endpoints. So some of the endpoints might be just for logged in users. So we want to have a middleware just to capture that and to throw back an error or an issue if somebody's trying to access an endpoint that they do not have the right to do so. So to continue on, we will create those middlewares. So the first one then is to do the authorise middleware. So we'll create a new middlewares, do authorise.ts, and just as before, we will import type middleware handler. So it's going to be a middleware handler. We're going to call it once. We're going to export it, of course. Export const authorise. There we are, if I can spell today. And this is going to accept scopes. So scopes are typically what we use to say what permissions a user has. And if you remember back onto our, if I go back to our types and our description of our user, we have a set of user scopes. We have a user could be an admin and a user themselves, and their scopes is a list of scopes, so they could have multiple scopes. So it could be user, which is our base class, which is so that's base permissions, and then admin gives them some additionality for being able to change requests or perform actions in our app. So in authorise, we're going to accept the scopes. So when we apply it to a router, we also define, okay, this route is only applicable to admin or a user. And we're going to return a middleware. Middleware handler based on this, and it will check for this, check the request to say whether the user has that scope. So it's got the request, response, and next function. Okay, and we're going to return authorise. And what we're going to do, as we have previously, we're going to just, as for the demo, just do log this event so we can see what's happening when it comes to running our app. Of course, in like a full blown production mode, you probably won't have these logging tools on. You probably might have a default global called debug, where you can input an if statement or something there to just log those as and when you would like. So let's get our locals. So our locals, and we're going to say that as our local variable. So they have type locals. That's it. Yep. So just remember where they're imported. That's oops. That's why they haven't automatically. I forgot the equals. So if I retype that, it should come up automatically. There we go. It's down on my IntelliSense. So now we say it's gather our locals from the request. Remember, our default local handler is automatically appending those, and we've got a authentication middleware that's going to unpack that JSON web token. So first thing we're going to do is just check if those locals user is equal to null. So once we've processed that request, does a user exist in that request? If not, we shall return a response. Oops, that's right. So just double checking response dot status 400 dot JSON, and and we're going to give them return an error, and we're going to say no user. We're going to just have data as null because we're not going to return any data into our JSON response. And now we're going to just check whether that locals.user.scopes, the scopes in that user includes the scope that we've specified in the function. And I've called it scopes there, we're just going to do a single scope in this application. Again, you could imagine that being a list of scopes that you want to validate against. Ooh. That should just come with scopes. There we go. So import that for us. There we go. Includes scopes, and again, if it doesn't, oops, if not. So this is we're going to exit early, and we're going to give it the response status 400 and the JSON again of an error, not authorized, and data is null. But if we pass all that, then we'll return the next function. So we'll proceed through our pipeline. And then the other middleware we'd like is the validate.ps middleware. And this is going to check the content of the request coming in, the body of it, and make sure that that body conforms to the need of that endpoint. So let's say it's a login user, we'll be requesting their email and the password, and that will then come through, and we'll unpack that here in the validate to check whether it's the right format, and if not, we'll ping an error of the what the issues are. So again, it's going to be, we're going to import a type middleware handler because it's going to be of that type. We'll call export constant validate, and we're going to say it's going to accept a schema of TS schema from typebox. So that's the schema that we're going to go and check against, and then we're going to create the validate function, and this is actually going to be our middleware handler. There we go, and it's going to be an async request. Again, add our request response next function into our arrow function here. Then we go constant data. We're going to extract the data from the request, sorry, not the response. And we are going to then do a check. So if not value dot check. Okay, so that's already imported from the type box there. If it's not, so here's our schema, I'll give it our schema, and if the data as well, so check our data. If not, we're going to return a response status 400. Oops. And give it the JSON error invalid. Oops. Request, and maybe we'll do C data for details. And in this data one, rather than typically using null, we're going to pass it the errors that typebox has detected. So that'll help us when we're developing our front end, just to check that we're feeding the right data there. Of course, if it's passed that check, then we can return next. And we will also, of course, return the validate function. So those are the two additional middlewares now that we'll be using in our user router. And rather than in the previous middlewares where apply them to every single call that's going in. These are going to be applied to specific calls as and when is needed. So now we can go and create our user router. So in going to routers, we'll create user.ts and just use pull my example across. And now we're going to define our user router. So to do that, we will first we're going to export a constant user router, and it's going to be a type router. There we go, from HyperExpress, and that's going to automatically import it for us. And we're going to say new router. So we're going to instantiate it, and now we can add endpoints to that router, just like we did with the ping. So the first thing that we want to do is be able to register users. So let's create the register function that will append to the register endpoint. So we're going to call this register. It's going to be of type user root handler from HyperExpress, and we're going to have it as an async request response call. Do our typical console log register. So I'm just going to, again, just for checking when we're trying to debug what's happening, I'm just going to say, oh, the register function's called, and it received, it was coming from request.url, just to make sure that we're appending it to the right URL. And just to remind myself where we got to last time. So yep, we did this function called types args context send. So we're going to use that to unpack our request to get a send function that we appended. We can then type the arguments that are coming in and the context send as well. So in here we are going to want to say constant. We're going to unpack that type args context send. So we're going to get the context and send, and we're going to await type args context send, and we're going to give it a type with register args. Okay, and we're going to create that in a moment. We've got to give it the request response. So there's going to be a few squiggly lines here as we need to send this, give it the argument type, and we need to define that. So we can define that in our types.ts. Again, these can be defined wherever in your code, but you know, it's out of consistency of where you'd like to define those. So if I just go and find my register args ts, where have I? Oh, I've lost it out of my example. I will, or my reference here. Just open up another workspace, which will have it in. Bear with me. And I think it should be in here somewhere. Here we go, types, that's the, okay. Apologies for that. So we want to do a register args, here we go. So again, we're going to create a object using typebox, so we get the automatic validation checks, and then we'll export the type from that. So we want to export, so apologies, export constant, register args, object. There we go. Okay, so it's going to be an object, and we want it to have a name. So they've got to provide us with their name, and it's going to be of type string. So we expect it to be a string. Oops. And we're going to do email, and that's going to be a type string. And we're also going to then give it some options to say it's got to be of a format email. And we need to define how we're going to check that email. So to do that, we can create something in typebox called a regex check for it. and we do that by creating a format registry entry. So we're going to add type box an entry called email. There we go. And we're going to call it email. We're going to give it a value. So that's the value that's coming in, and I'm going to just copy and paste this because it's quite verbose. So yeah, look in the GitHub repo associated with this to perform that check. Oh, actually, we can just put that into a single line check. There we go. That's it. There we go. So what it's doing is there is a regex there, regular expression, and it's checking all the different bits, and it's going to do the test on that regular expression against the value. And if it's an issue, then it'll raise that and report that back to us. So we've got the email. We're going to ask for confirm email. And that's exactly the same. So I'll just copy that across. There we go. We're going to do password. That's a type string as well. And you can imagine there as well with the password. We won't be doing it in this demo, but you could imagine adding a format registry item there to make sure that the password contains features that you might request in the password. So make sure it's got numbers, wildcard like underscores and dashes rather than just pure text. And then additional properties false. So we're only expecting those 1, 2, 3, 4, 5 items. So yeah, name, email, confirm email, password, and confirm password. So that's our schema to check against. And then we're going to export register args. This is then creating the type or TypeScript to check against as well within our code, and we need that static, and that comes from type box as well. So just import that up there. So we'll get no wiggly lines. So that's our register args that we're going to pass to our function up here in users register args. So now we've got a type, so we know that this should be, there we go, it's already highlighted to us. We're expecting those arguments to be passed. We've got our context and we've got our send. And when we attach this router, route to user router, we are going to then also have the validate check, which will validate against that register args. So, right, now we're going to do some additional checks now. We've typed all that. So first thing we're going to do is check the email equals args confirm email, and we're going to return, oops, of course, if not, oops, if not equals, just clean that up, there we go. Return send, we're going to send 400, and we've got our typing to say, there's an error, emails do not match. And data equals null. Okay, next one we want to do is just do the same for our passwords. So if I just copy and paste that up to save a little bit of time, we can do exactly the same here, just password, confirm password, and then just say passwords do not match. Now we've got that, we are going to check now our database to make sure that our database doesn't have a user that exists already with that email address. So we're going to try and grab the user. So we've got to bring our context. It's got our users collection in there. We're going to say .by. We're going to try and find them by email. Remember, we used the email as our index alongside our ID, and we're just going to pass it the email up from the arguments. And if a user exists, so if it's defined, therefore we do have a user, we can then send a 400 response and detail the error as user already exists. And of course, this would go back to our front end app, and if you detected that issue, then you might be able to raise a little question. You may already have a login, please log in, or send them to the login screen. So that's just checking with the user. So if we've passed that check, then we can then go, right, okay, we've got a valid new user who wants to join our service. So we want to then encrypt their hash, encrypt their password, so we do not store the, oops, we don't need to do that. We can do random bytes just from crypto, and let's just import it. We're going to encrypt that password, so again, and hash it, so we never store passwords in plain text. We're going to use the same format as we did with the admin, so we're using the PBKDF2 sync. We're going to pass it the password, salt, value 310,000, 32, and we're using the SHA 3x6 algorithm. Okay, so that was all as we were before with the default admin user. And then we're going to try and add them to the database, and if there's an error, we're going to bring that back. So we're going to create a user of type user, so that will come in from our types. We're going to create an ID, random, oops, it equals up here, random UUID. Name, we're going to then just pass it in the args.name, email, args.email, and the hash. We are going to just return the hash that we've just created to string. I'm going to store it as a hex string. And the salt, again, salt.toString. Because when we create those, they're in buffer objects. Okay, and then we're going to give it default scopes, user scopes dot user, and yep. Okay, so now it's just giving us an error there just to say we haven't used it yet. That's no problem at all. So now we just want to go to the users collection dot insert, and we're going to insert that user. And if we've managed to get past all of those steps, we can send a 200 and error null, got no error, and data, we will just write a little string called success. We have successfully added a user. In any of those steps, if an error is raised, there we go, we will then return an error. So send, let's say this one way of 500, because we might not sure what the actual error on the database is. Just for debugging, we want to, might say, report us that message and say data.null. There we go, so that's going to report that message. And that is our register user handler. So from the top, we are unpacking our request response to get the arguments, the context, and the send command, just wrapping those out to make them easy to use functions. We're checking the emails, we're checking the password for consistency, reporting if not, checking if the user already exists, and if not, then creating the user and storing them in the database. Now we just need to add them to our router. So we just put our user router here. We're going to put this at the end point. We're going to do a post request, and it's going to put it on the register endpoint. And here is where we're going to add those extra middleware. So here we want to do the validate one. We want to validate this request with register args. So it's going to do a check on that formatting of the emails are a valid email address. And then we're going to pass it to our user handler function. So it will go all through all the middlewares that we had previously in the top level in the index, then to our validate, then to our register. So that's register. Now we've successfully registered a user, maybe we want to log them in. So the next one would be const login. And again, user root handler. We're going to do is async request response. The arrow function. I'm going to just copy and paste at the top. So as always before, we'll do our console log, and we will do our type arg sense. Just go call that login. And this time, rather than register args, we're going to create our login args. So we go back to our types. We do export const login args, and again, it's going to be type object, and we're going to have email. I'll copy that up at the top there. So we're going to have our email dot string, and we're going to ask for the password as well. So we're going to have the password in there. Oops. Yeah. Should be that. Where have I misplaced that? Type string. I've put it within the email. The perils of copy and pasting. Yeah, so we just put it there. There we go. And then also we want to say additional properties false as well. So just the email and password in that object. Okay, and then create a type for it. So login args equals static type of login args. Now we go back to our user router. We start writing login args as a type. That should automatically import it. And as we go to the top, there we go. We'll start bringing those in from our types.js file. Now we can start building out the logging function. So we're going to first find the user. So in our context, it's going to be our users collection dot by. Again, we're going to find them by email because there should be only one user with that email address. So args.email. If not user this time, we're going to return an error. Send. This time do another 400. At the moment, I just put them as 400s. Again, there's different error codes. Worth looking at the appropriate codes for these. Again, just for expediency, I'm just using 400 for any errors at the moment. Exist. So just saying that the user's not there and data is null. So I'll put there as user. So that as user. So we're trying to find the user and the user's collection. We are checking if it exists. If not, then we'll say the user doesn't exist. You can imagine then going the front end app, then proceeding to the register page. If not, we're going to try checking their password that they've provided us with is equal to the password of the user that we've gathered from the database. So we need to pull the user.salt, and we're going to now put that back into a buffer form. So we've read that result from the database. We're also going to copy and paste that and do the hash. So user.hash. Then through that, we are now going to do our password hash. The PDQ sync, there we go. And this is where we're going to hash up the password that they've just provided with the salt that we've got from the database. Again, hard-coded values of 310,032, and SHA-256 as the algorithm. And now we want to try and just check. So we're going to do timing safe equal from the crypto package. We're going to check hash from our database with the password hash and see if they agree. Oops, PW hash. And if they do not, so here, if they do not, we're going to return an error again. And put the error as passwords do not match. Data. But if all is good, then we want to now create a JSON web token for that user. Okay, so that's going to be their authentication that they're going to pass through the header on their subsequent requests. So we're going to import JSON web token, and because JSON web token doesn't have its types defined within its own library, just got to import it manually. So there, JWT dots. We're going to assign a token. Oops, first of all we need to create the data for the token. So let's create that. So we're going to have, they're going to have that user ID passed to them. They're going to have their name, so they know who they are. They're going to have their scopes as well. And we're also going to create the IAT, which is the expiry date for the token. And you can have it as long or as short as you'd like. So what we need to do is get the date as it is now. And we are going to do this as a 24-hour date. So we're going to get the date and we're going to forward it 24 hours for the expiry date. So it's valid for 24 hours. So the front end and the back end should be checking for that, and we'll then return the user to the login screen once that passes. Or we'll introduce a refresh token. So if the user is still being active on the front end, then it should recognize, oh, we're coming close to that time. I'm going to refresh that token for the user. So then we go, now we're going to assign that token and give that to the user. So, we're going to put global vars, there we go. So go back to all the way back to that beginning where we added some variables. So global variables, so we're going to take our secrets and we're going to use the HS256 algorithm to sign that web token. Oh, it's automatically reduced that. I need to find the option there to turn off the automatically remove my imports. JSON. There we go. So I've imported that. There we go. That's all signed. It's now still highlighting that we've got an error with our token because we haven't used it yet. Now we can return send 200 and data, and we'll put it in the bearer format. Then the front end simply needs to manage and place that in every single header, now subsequent header that the user sends. The last little bit here is if there's any errors when we're trying to attempt to do any of those tasks, we will then return a 500, because I think this one's like more of a critical server issue. Error equals e.message and data equals email. And managing that bearer token there that we've just created will be part of the client's role. So again, that's it. Actually, the front end will not have to worry about it. If it uses our client that we create for it, then it'll all be fine. So again, I think I should just have a quick rundown on this then. So yeah, this is a login user. We've done our type args context to unpack it for some nice utility functions and get access to the variables. We have created this login args, which requires an email and password. We check whether the user exists. We then take the salt and hash from that user, put them into buffers, so we can then create the password hashes and check if they conform and are equal to each other. Then we create the data structure for the JSON Web Token, which then gets signed by the JSON Web Token package. We then send that on to the user. So they've got a nice valid token using our secret. So any subsequent requests, we know that user is authenticated with our application. So now we need to attach that to our user router. So we do another post. Let's call this one /login, this endpoint, and we're going to do another validate. And we're going to validate against our login args. So again, that's going to do all our just standard checks of the formatting and structure of those arguments ahead of going into our login function. So I mentioned before, like you said, this is 24 hours. So the next thing we could do is create a refresh token endpoint. So if the user is still active, coming up to those 24 hours, we can automatically refresh that token for them. So we can do that by creating a function refresh. And this is again, user root handler, async function, request response. Oops, need the comma there. And we'll create the arrow function there. And this time we're going to extract the context and send commands from our type type args context, send that request and response. In this case, we're not using we're not expecting any arguments to be sent by the user, because it's just purely we're going to actually access their header and get the authorization and just update that token. The fact that actually if they get to this stage, because we're going to be checking the authorization along the way, we'll just go, okay, yep, we'll then refresh the user token from their context. This is a case of just getting data, because we've already checked that the user is valid, so they can refresh at any time. And we just go ctx.user user.id. Oh, there we go. Actually, we can do a check here. If ctx does not have user, we will then return an error because they shouldn't have got there. So we can do error. Oops. No user data null. There we go. So that's just checking that the user is in that context. It should be already by the time it gets here. So then we don't need that exclamation mark there. So just as we had before, we will then again just take the email, user email, and scopes. I can keep their scopes that they had. And IAT, we are now going to, I'll just copy and paste that math.floor at the top, bring that back down. Again, we're going to renew that token. And again, we can just simply copy and paste, Control C, Control V, the creation of that token using our JWT secret. Return and 200. Again, I can just actually copy and paste that. Go return send 200, the new bearer token, and then the client can then store that one. So that's the simple refresh function, and that can go to user router dot host register refresh endpoint, and we will we don't need to validate it, but we do need to authorize it. So we're going to say, actually, this time we're going to use our authorise middleware that we've created, and we're going to say, does the user have the scope user? So are they a valid user? So one, that authentication, are they a valid user, and do they have the scopes user? We'll use then the refresh function. Cool, so that's pretty much it, apart from, I think there's a couple of things of like updating scopes and posts and me next. So I think we'll do the me one next, which is just to get my my own data. So just get a bit more information about myself. So at the moment, you know, token's got the email and name and stuff, but if you imagine you'd have a user with a lot more information about themselves, you wouldn't pack that into the web token. You'd then probably do a me request that gets you all the details of that user if they wanted to have their own like user settings page. So let's do we'll call it the function me, a user root handler, and we'll do it again. It's a async request response. So hopefully, as you see, you're probably seeing this familiarity in creating these user root handlers. Oh, I don't need these on actually. And we can create a ctx -send. Wait, the type args, and then we just need the request and response, pass that through. Again, the first check we want to do is just check that there's a user in that context. If not, then we will return then 400 with an error, no user, null, and it should do a console.log as we have been before. Me, double check where the request is coming from, double check with the request. We can do that to this one as well, to the refresh. Request.url. So now we've just checked that the user's existing, so now we can go to the database and get more of their data. User collections by, this time we can do it by ID because we've got the user ID, ctx.user.id. If for some strange reason, it's always worth checking, if there's no user, then we'll return send 100 error, no user found. And data no. But if we do have a user and we want to return send 200 error null, and the data is user. So we're just sending them the actual their user information. And if you remember, it goes back through that sanitize function, so it'll strip out any the salt of the hash, the low key arguments about the keys in there. So we know that they're not going to get any information that just should remain on the server. So we can do, this time it's a user.get, so we just need to attach it. get me, because we're not actually asking the server to make any changes, so that's what you typically use for post requests. You're just asking for information. We use a get request, and we will then just double check that the user is logged in. So if they are authorized with the default user scopes.user, and if all is well, then they can then go to the me command. So that's 4 of those. So I think we can do, I think, given, I'm just checking the time then, how long have we been running for? 45 minutes. There is a couple more, which is updating passwords, but for this demo, you can have a think about how you might want to change that. I might include it at the very end once we've completed the application. And then there's the patch command, where we can update the user's credentials. Again, because we're not going to be using it in this demo, we're just going to have register a user, log them in, then add some to-dos. But you can imagine there, that's again similar, same functions there. Create the user, create the patch command, which would get the user, check the arguments for whether the patch that they want to make is valid, make those edits, update that user's collection. Same with the password. But the password with the additional one is, if you've got an admin, you might want the admin to be able to do that. So you can authorize that for admin. Maybe you want to check the user against whether they are the user or whether they're an admin user, and then make the changes to the password there and then. So now we've got these, I think these will be sufficient for this tutorial, but you can imagine how they continue growing. We will then need to just attach that router to the global server, the actual server. So we go back to index.ts, and then just below our API, we can do app.use /API/user. So we're going to put these on /API/user/login/register/refresh/me. So that's how the endpoints can concatenate and build up. And we're going to give it user router from routers. So I think that's a good point to stop there. So now we've got our full user endpoints. Next steps, I will be looking to create the tests and actually start building out our client. So what we're going to do is actually build up our client package, and then use that in our testing function to boot up a server, use the client, then perform the tests against those endpoints to check they're valid. Again, we'll probably do a few examples of the tests. So we're not going to go, do a complete test suite, but enough to get you familiar with how to build tests for this application. So thanks for watching. Hope to see you soon.